Isaac Newton was a giant in the world of science. Born in 1642 in England, his life was dedicated to exploring the mysteries of nature. Newton's contributions were vast and varied, delving into physics, mathematics, astronomy, and even alchemy. He's most famous for his laws of motion and universal gravitation. These laws explained a wide range of physical phenomena, from the fall of an apple to the motion of planets. Newton also explored the nature of light and color. His legacy continues to influence science and beyond. Newton's genius laid the groundwork for future scientists. Even today, his work remains a cornerstone of scientific education. Newton's laws of motion are fundamental to physics. The first law states that an object will remain at rest or in uniform motion unless acted upon by an external force. The second law explains how the velocity of an object changes when subjected to an external force, summarized by F equals ma. The third law states for every action there is an equal and opposite reaction. This law explains interactions between two bodies, enabling walking, flying, and rocket launches. Newton also formulated the law of universal gravitation. He proposed that every particle in the universe attracts every other particle with a force proportional to their masses and inversely proportional to the square of the distance between them. This was revolutionary because it applied universally, from apples to planets. Newton's laws provided clarity and insight into the natural world. Explanations were instrumental for the scientific revolution. The confirmation of heliocentricity marked a major shift in scientific thought. Newton made significant contributions to the field of optics. He discovered that white light is made up of a spectrum of colors through his famous prism experiment. Newton demonstrated that light is made up of particles, contrary to the wave theory of light. His work laid the foundation for the future study of optics and light behavior. One of Newton's most significant inventions was the reflecting telescope. Newton's design used mirrors instead of lenses, improving image quality and allowing for more compact telescopes. The reflecting telescope was a major advancement for astronomy. It enabled clearer and more detailed observations of celestial bodies. Newton's design is still used in telescopes today. Newton's work in mathematics was as groundbreaking as his work in physics. He developed calculus, a new branch of mathematics dealing with change and motion. Calculus was developed independently by both Newton and Leibniz. Newton's approach was more geometric, while Leibniz's was more analytical. Calculus became essential for scientific research, allowing for precise calculations in physics, engineering, and beyond. Newton also contributed significantly to algebra and geometry. He expanded on the binomial theorem and introduced concepts fundamental in mathematical analysis. His contributions to mathematics laid the groundwork for future discoveries. Calculus and the binomial theorem remain vital in scientific and engineering fields. Newton's interests were not confined to the sciences. He delved into alchemy, an ancient practice combining science and mysticism. Newton's notebooks contained many alchemical experiments and symbols. Though alchemy was not a science, it influenced his thinking. Some historians believe it inspired his work on the nature of light and matter. In addition to alchemy, Newton studied biblical chronology. He tried to align historical events with biblical narratives. These lesser-known pursuits illustrate Newton's diverse interests. They show a man driven by curiosity and a quest for understanding. Isaac Newton's impact on science is immeasurable. His laws of motion and universal gravitation changed our understanding of the physical world. His work in optics and invention of the reflecting telescope revolutionized astronomy. His development of calculus provided tools for countless scientific advancements. Newton's inquiries into alchemy and biblical chronology revealed the breadth of his curiosity. His legacy extends beyond science, influencing philosophy and theology. Future scientists like Einstein expanded on Newton's work. Despite advancements, Newton's principles remain foundational to modern science. In summary, Isaac Newton was a pioneer whose contributions transcend time.